Do we have the correct definition of gravitation? I am Zoltan J Kiss, an engineer, independent researcher, and I prepared this video for discussing this subject with you. And we will not speaking about the validity of these formulas. We will discuss the contradictions of the misinterpretation of gravitation. I don't want to agitate you, but I do my best to convince you about my findings. For starting, we are going to use a small scheme for explaining the root of the contradictions. First, we take two objects of equal mass values. In this case, there is an attracting force developing between the two objects, which is moving the two objects towards each other. Now we change one of the objects with higher mass value. In this case, the relation of the mass values is inversely proportional to the displacement of the object. Very simple. The first question is, what is the source of the attracting force? And the second question is, why the mass? Equal mass values could have different densities, and different densities may have different size. So in this case, the displacements could be impacted. And the third question is, what really the attraction means on its merits. Now we change these objects with the Earth as a planet free for movement, and an object in free fall. The question is, what will be happening? The difference between the mass of the Earth and the mass of the objects are of many, many magnitudes. But the Earth as an object are equal parts of the relation. If we review or assess the situation from a point of view of the Earth, in that case, we also have to examine the case from the point of view of the object in free fall. This is not about the difference in mass values and the practical meaning of the relation. This is a principal point. In practical terms, it makes no sense to evaluate, obviously, because the relative movement of the Earth would be so small. But we are not looking at this from the point of view of the practical results. We are taking a look from the point of view of the relativistic relation. And for assessing the case further, we built up a small scheme with the Earth first, with 4 objects symmetrically positioned, and again ask ourselves, what will be the case? The golden plate just for demonstrating the equal distance. So because the equal distance and the equal mass values, there is a balance. I wouldn't say the objects are establishing the position of the Earth, but the balance is keeping the Earth at the same place, no movement. So we now are complicating a little bit the situation. We change 2 objects on the left and on the right, with the red one with higher mass value, and the golden one is over higher mass value than these 2, and the red one is representing a mass higher than the golden one. In that case, the situation is a little bit more complicated, and asking ourselves again, what will be the case? And for assessing this, we are taking 2 scenarios. The first scenario is that the Earth as a planet stays at its original position. In this case, we are in compliance. All objects fall at the same rate. But at the same time, we are in non-compliance with this formula because attracting force here developing between the mass with higher mass value is clearly more and the attracting force developing between the mass with less value and the Earth. And if the attracting forces are different here and here, in that case, the Earth simply have to move some direction, obviously in this direction. So this is a contradiction. And now we suppose the second scenario, when we suppose that the Earth is moving toward the object with higher mass value. In this case, we are in compliance with this formula, because the attracting force here is more than the attracting force here. But we are not in compliance with the same rate of the free falls because of this delta S displacement difference. So again, a contradiction. And in this case, we also have to note that the movement, the relative movement of the Earth is happening between these two objects, down and up. And the direction of the free fall toward the center of the Earth is, because of the movement of the Earth, is changing. So the reason is clear and the outcome is clear. Now, we still may exaggerate the case, even deepen the contradiction, if we put different objects all around the Earth at different distances and with different mass values. In this case, because there are a lot of attracting forces developing between the Earth and the objects, the movement of the Earth as a planet would be established by the mass values all around us, which is obviously, it's very difficult to understand, or would be a very strange situation. These small, simple experiments show those contradictions which cannot be overstepped without the clarification of the real issue. And now, finishing this explanation and examples, we go back to the presentation. We can pose the question again. Do we really have the correct definition of gravitation? Is the missing correct definition influencing the missing definition of other categories of physics? Does the empty space as such exist, for example? Do we have the answer? Does the vacuum have its valid definition? Do we know what is the vacuum is? In this case, the definition of the speed of light is also under concern because it is defined in vacuum and empty space. So nothing is such, doesn't exist. Is the empty space covering the nothing? Or the vacuum is the something which contains nothing? In this case, really, the definition of the speed of light is with problems. So another point is the elementary particles and processes. If the elementary particles have lifetime, why we don't call them elementary processes? Or without the correct definition of gravitation, do we have the chance to define the magnetism? And I tried to answer those questions I raised during this small exercise. So what is the source of the attracting force? And I'm asking ourselves, could it be different than our internal energy? If we are attracting each other, could the attracting force different there than from the source of our energy? And if we want to describe or write down the use of the internal energy, this is the formula. This is in relativistic way, but this is covering the case. And the question is, why the mass? The same masses could have different densities. So, and the different densities of the same mass value can influence the displacement of the objects. So, would it be more correct to write this formula this way? This is the same formula just divided by the volume. In this case, the changing internal energy is expressing that the density is changing. The density is coming down and will be less than earlier. What the decreasing density means, an increasing internal volume of the same mass. So why the density? Has the density a certain specific meaning? Yes, it has. Because if we take this formula, it's a classical formula, energy, this should be correct in this way as well, invalid this way as well. But this formula means the appearance of the energy with the speed of light. So the mass is not other than the appearance of the energy and information and impact with the speed of light. And if we are turning to the density and start to formulate this principle in density values, it means that density is not other than the concentration of the energy. Here we didn't do more than divided these two parts of the equation by the volume and getting to the density. The density in other meaning also expressed as a space parameters as well. If we accept the density is a critical parameter making a decision of the definition of the gravitation, in that case we can say that the attraction is not other than the decrease of the density, the increase of the space. And if this relates to the gravitation, in that case the gravitation is no other than the release of the internal energy of the Earth. The generating energy is making the surface spherical. The external impact makes the surface hyperbolic. We can give the proof in the conventional way as well. So we use just Planck, Newton, the classics. And the result is the gravitation constant is coming as the usual value. And for calculating this, I don't want to go through all these deductions and all these substitutions, because you can stop the video and take a look in details and go yourself to control it. But here is a very important formula, the surface power density, the drive of the sphere-symmetrical expanding acceleration. And if we take a look at the gravitational coefficient, then we see that this is a constant value, and also this is a constant value. So we have a constant gravitational coefficient. The only difference is that for having this value here, Planck force should be this value instead of the literature this value. And the difference is by 25%, the value of these, magnitude of these values are so big that this easily can be taken as two equal values. And having the relativistic proof and having the classical proofs, we just come to the definition of the gravitation, which is the sphere-symmetrical expanding acceleration of the Earth as a planet. And if we want to have a practical experience proof, in that case we just go to the Harvard blue shift redshift experiment and becoming the same result as was earlier experienced. If the surface of the Earth is coming up because of the expanding process of the Earth's surface, and we release here a frequency upward, until the frequency going to the measurement place, the tower is going up, and here the frequency will be redshifted for sure. And the opposite side, if we are releasing the frequency from here, and in the meantime the Earth's surface is coming up, it will be blue shifted. So this is the same way as earlier. The Pound-Repka experiment is proving the definition of the gravitation. And if we want to make the conclusion and answer the question earlier at the beginning of the presentation taken, the definition of the gravitation as a sphere-symmetrical expanding acceleration of the Earth as a planet is valid for any numbers of objects, for any mass values, for any distances from the center of the Earth. And this definition gives the freedom for all falling free at the same rata and always toward the center of the Earth. as in fact the Earth is the one whose the surface is approaching the objects, and gives the proof that all objects are weightless during the free fall. Please realize that the space-time and the relativity are far not theoretical, but practical categories. I will show now a small video for helping to understand this. This video shows how the speed is influencing the elementary processes. With this increasing speed, the intensity of the process is increasing, which increases the resistance of the lamp inside. And because the resistance of the lamps inside increasing, therefore the light is disappearing. And when we slow down the speed, in that case, in the opposite way, the light is coming back. So coming back from the video and speaking again about the space-time and the relativity, we also have to understand that the intensities of our space-time and the intensities of the Earth's space-time as a planet are different. Our space-time on the surface of the Earth are speeded up. Therefore, all those events which happen in the space-time of the Earth as the expansion and the asymmetrical expanding acceleration appear in our space-time as a slow events, difficult to realize. I leave the judgment to you. Is the apple is falling towards the Earth's surface, or the surface is coming up to reaching the apple? Thank you for your attention, and see you next time.